We're continuing on with absolute value inequalities, but now we're going to talk about absolute value inequalities that include a greater than or equal to, which is what all of these examples have here. So if we start off with a super basic example again, we can apply that when it gets a little bit more complicated. In part A, it wants to know the absolute value of x is greater than 3. So again, absolute value is the distance from 0, and now it must be greater than 3. So that's what's wrote out right here. This means that x must be more than 3 units away from 0. Well, where are we talking about on this number line that my units are more than 3 units away? Everything in between here we discovered last time means that they all have an absolute value of less than 3. Now, if I want it to be greater than 3, I am talking about this portion of my graph, and I'm talking about this portion of my graph. Here's where I have all these absolute values that are bigger than 3. So how would I represent this portion right here as an inequality? Well, this is when x is less than -3. Use that arrow to match this arrow. And then over here is when we have x is greater than 3. These are our OR statements. So when it asks me to solve the absolute value inequality, these are our absolute value inequalities. And when we have OR statements, we don't put these as compound inequalities like we did last video. So solve the absolute value inequalities, check, check. Graph the solution set, check. Now let's express our answer in interval notation. In interval notation, we have two different sections, and this kind of goes back to what we did on the very first page when we had a not equals to. We have two different portions that are shaded here, so I need to talk about each one individually. This side over here represents negative infinity to -3. Leave a little bit of room here. And then over here we have 3 to infinity. Now, when I have multiple sections of this graph shaded, I need to combine this when I have my ORs right here with the U. And this U, let's do it in pink. This U right here stands for the union. There is my interval notation. Okay, so let's apply this. When I have greater thans, we're really doing the exact same thing we did with less thans. We just then need to pay attention to the shading. My first equation is going to be exactly what this looks like without those absolute value bars. We have x is greater than 3. And then the next one, we'll take whatever's in those bars out still. X, flip that symbol, is now less than -3. So on B, what do I do first? Hopefully you can see that my absolute value is not isolated here. So I need to add that 1 over. And so I'm going to get the absolute value of x is greater than 20. Now I can write my two inequalities. The first one looks exactly like this without the bars. So we have 5x is greater than 20. And then my second one, that 5x still comes out. Flip this to less than, and now it will be -20. You cannot separate this into the two until after you isolate. You'll get one of the two solutions wrong if you don't. So now here, divide by 5, and we get that x must be greater than 4. And then here we get, divide by 5, we get that x is less than -4. So if I was to graph this, and we have -4 and 4, shade the regions that they're talking about here. We're greater than 4, so that's to the right, parenthesis, because it's greater than. Here we have everything that is less than -4, and it's less than, so parentheses. So in interval notation, we need to talk about these two different shaded regions separately. This one is -infinity to -4, and then the union in between, this one represents 4 to infinity. Last one here on C. Can I separate this into my two equations? Yes, the absolute value is isolated. Here, we had the absolute value plus 1, so I needed to add that 1 over. But this one's just the absolute value. So now we have 2 minus 3x is greater than 1. And then we'll have 2 minus 3x, flip the symbol, is less than or equal to -1. So if I solve this one, I'm going to subtract my 2 over to get -3x is greater than or equal to -1. I'm doing 1 minus 2, and then divide by that -3. 1 over 3 does not reduce, but negative over negative becomes positive. Ooh, and what happens as well? Let's just go ahead and write this. When I divide by -3, we said negative over negative becomes positive 1/3. But because I am dividing by a negative, flip that sign. So we have x is less than or equal to 1/3. And then what do we get over here? Subtract your 2 over. We get -3. Again, divide by -3. And we're going to now get x is greater than or equal to 1. So graphing, we have 1/3 and 1. And shade as they say. X is less than or equal to 1/3. So we're shading to the left of 1/3. And because it's or equals to, this one will get a bracket. And everything is greater than or equal to 1. So we're shading to the right. Use that as an arrow. And a bracket again. So interval notation here. This side here is -infinity to 1/3. -infinity is a parenthesis, but 1/3 will have a bracket. It's okay that that's going to be highlighted in red. We'll put the union in between, and then 1 to infinity on this side, bracket to parenthesis. So you can see here, what do these all have in common? Every time we have greater than, we're shading the outside portion here. These are our or statements. Okay, now it really doesn't matter if you memorize that greater than or equal to shades on the outside, if you use this to shade your graph correctly. But the pattern is these always will be these outside portions while you're, let me find it. While your less than or equal to will always be that middle portion right there.